Welcome to second semester calculus. You might be asking yourself, why am I staring at a list of indefinite integrals that I learned in Calc 1? Thought this was an introduction to second semester calculus. Well, in this video, we're going to try to explain how all of the integration techniques that you're going to see all fit together. And this is going to be our table of antiderivatives. And my contention is that this list of improper integrals, or indefinite integrals, are the only indefinite integrals that we can actually solve. And the rest of this video will show what our integration techniques are trying to do and how they all fit together. Now you might say to me, Professor, I know a lot more than just that table of antiderivatives. In first semester calculus, I learned U substitution. So I can integrate much more complex things, like x times sine of x squared. To which my response is, well, the final step in U substitution gets us to our table of antiderivatives. So the point of U substitution is to help us reduce a complex problem down to something off our table of antiderivatives. And then you might say, well, in my Calc BC class, or I looked ahead, I know that we're going to learn integration by parts. So I can integrate functions like x times e to the x, where u sub isn't helpful. Well, when we use integration by parts, again, we end up with an integral that is off our table of antiderivatives. We'll also learn in this class about trig substitution, where we'll take incredibly complex integrals that involve compositions, as well as products, roots, all kinds of nasty things. But at the end of the day, we get an integral that is off our table of antiderivatives. Even more so, if you just really enjoy algebra, we'll also learn partial fraction decomposition, where we'll look at integrals that are going to be a ratio of two polynomials. That looks incredibly difficult and complex, but we'll just simplify it down to a combination of functions that are in our table of antiderivatives. So you know you're done with our integration techniques when you end up at the table of antiderivatives. All the techniques that you are going to learn in the first month of this course will have a lot of steps, and it'll be very difficult to use to understand which is the appropriate method, what are some of the substitutions I need to make, what decisions. There's a lot of decisions to still make, but you know you are finished when you end up at the table of antiderivatives. Now, it's not so simple as just I pick a method and get to my table of antiderivatives. I can have functions that may not be obvious which method I'm going to use. But after doing a U substitution, I'll turn this integral into something that's into integration by parts, and then I can get into my table of antiderivatives. Or I might have a function where I'll use U substitution, and after U substitution, I'm going to turn it into partial fraction decomposition. So there's going to be interplay between these methods, and in fact I can do that for everything. I can think of problems in which integration by parts is going to turn into trig sub, or trig sub might turn into integration by parts, or my partial fraction decomposition will get me into trig substitution. I'm going to have to use multiple methods, but all of those methods are going to end at the table of antiderivatives. So as you go through these methods, two main things we want to keep in mind. The formulas that we're going to use, the steps that we're going to use, are going to need to be automatic, because the hard part is going to be deciding which of these tactics we're going to use and how many we're going to use. But we must know the second to last step of actually applying the formulas. That has to be automatic. And we have to know when we're finished. And we're just going to keep trying to simplify all these complex integrals. We don't have to ask when we're done or if we simplified it enough. We're going to keep working until we've got it down onto the table of antiderivatives. And this is going to be the focus of our first month of class. Thank you. Welcome. I look forward to working with all of you.